Hello, statistics students. We are going to do a deep dive into Chapter 9, Section 5. And I can understand why this section up to this point feels like a lot. And it's because it is taking three concepts, the z-test, the t-test, and the proportional z-test, and putting them all together in one unit. And in fact, if you're taking this class during the summer, this will probably feel like a whole lot, because instead of taking a few days to kind of go over the notes and absorb and do them, you're going to have to do this in twice the pace, which is half the time. So I want to kind of do a greatest hits of Chapter 9, Section 5, and condensing a lot of the questions that you've asked or going to ask if you're watching this ahead of time in this section. So the first thing is that all of these hypothesis tests is essentially doing one thing, which is checking to see if the hypothesis is wrong. And the null hypothesis is what we assume is true. So an example that I have is, what if I believe that 40% of people who live in Battle Creek, Michigan have a cat? That's my null hypothesis. Now, if I go and run and do some data, and I find out that the number that is truly in that sample, which happens to be a representative sample, is extremely far off of my 40% calculation, then I'm going to have to reject the null hypothesis. And this is because when I run the numbers, my z-score or t-score will be so many standard deviations away from the norm, the chances of me accidentally getting that would be near zero, or definitely under 5%. Then we would throw away my idea that 40% of all the people in Battle Creek, Michigan have a cat. So let's kind of go through problem by problem, and I'll preface this discussion by saying that I won't run through all of these problems. I won't kind of walk through each of them. I'm just going to highlight different parts of them that may need to be explained a little bit more than in the videos that I've given you so far. So let's first of all take a look at the first part of each of these questions, because you have to decide whether you're going to use the proportion z-tests, the z-test, or a t-test. So there's three different tests on your calculator, and you got to decide which one it is. The proportion or the percentage z-test is the easiest one, and it's the easiest one because it has a percent in it. It's what we're going to be checking. So my example to you, which was 40% of all people in Battle Creek, Michigan have a cat, that is an example of a proportional z-test. And another factor of this is that the sample size is going to be pretty big. And in fact, the sample size, even being 30 people or more, still might not be big enough. So we have actually a more important check to do, which is in part B of this preliminary work. So in the preliminary work is a question that says, is it safe to assume that your N is less than 5% of all subjects in this population? And because I give you 3 chances per problem, you can easily get this question right by guessing or watching this video right now and understanding what the actual answer is. And it's the same every time. The answer is yes. The answer is yes, that your N is less than 5% of all your subjects of the population, because once you kind of hit a threshold bigger than that, then we have to do some more rigorous work. And well, we're not going to be doing that. So you're going to click yes, because if you had to click no, and no is the correct answer, then we might be doing some different testing, or at least testing that I wouldn't be covering in this class. So your answer is yes for all of these questions. When N is asked, is your N, the people that you're surveying, less than 5% of the subjects in the population? Because, again, if the answer was no, then we wouldn't be going any further, and that would be a very short problem with a lot of blanks not filled in. So now I've thought about eliminating that question, but why throw away easy points on a test, right? So click yes and move on. Now, what we have to do in the preliminary work here is we have to verify that the N times the P naught multiplied by the complement of P naught, which I've called it Q, because the P being a success and then Q being a a fail in that situation. Both numbers, percentages will add up to 100%. So doing that is pretty straightforward. I can use a normal calculator for this, just a standard calculator. I can take my n, in this case 100 adults, so 100, and multiply that by my p0, which is the original 84% null hypothesis, 0.84, and then multiply that by 1 minus p0, and that p0 in this case is going to be 1 minus 0.84, which I can do in my head is 0.16, because that will give me 13.44. And you can even do this on the calculator, graphing calculator, and you can do it on this graphing calculator in one string if you wanted to. And I think it would be nice if you do hit the mode key, make sure you are in classic mode. By being in classic mode, you can see a long string of numbers on the screen at the same time. If your calculator doesn't have a classic mode option, then it only is in classic mode. So after you hit mode, click second and then mode. And then now we're on here, and of course using the phone app may not have that as well. So what we can do is type in the 100, type in the 0.84, and I'm using parentheses here, and then parentheses 1 minus 0.84. So this is matching exactly the step here, and you can see that it's 13.44. So that is really nice to have on a graphing calculator. Now, a little bit about the notation that that XYZ wants. When you express the null and alternative hypothesis, make sure you put the p there. It would be p for a proportional z-test. If this was not a proportional z-test, you could use the letter u for mu, or you could type in mu. But most of the questions on XYZ homework do not even let you input a letter for the Greek symbol mu when you do a z-test or a t-test. So having a big blank here is a big symbol to do the p equals. And now what's most important, it says it's 84%. This is going to be pretty persnickety about this, so you're going to make your p0 with a 0.84. Make sure you put the 0 in there, and that is again what XYZ is going to want. And then after the null, then you're going to hit your alternative hypothesis, and your alternative hypothesis will be what this is asking about, whether it's higher or lower. And the researcher in this randomly generated problem said decreased, so you're going to have less than. Then what you do is you're going to go into your calculator and then compute into your stat, move over to your tests, and this is a 1 proportional z-test. So option number 5 on this calculator, and so I hit the enter button here, and so my proportion is going to be, my p0 is 0.84. Now, don't go back up to the top, because now what we are seeing that in part B it says, after surveying 100 adult Americans, the researcher finds out that 23 people support stricter gun laws. So there's my X, my 23 are those who support stricter gun laws, and then my N is 100. So here's my 100. So now it asks for me to calculate the z-value, and then it will give me the p-value. I would warn you that usually the alternative hypothesis will match the symbol here, but every once in a while, you have probably a 1 in 8 chance of this happening on your homework assignment. Every once in a while, they won't match, because this researcher here believes it decreases. So here you'd put your p is less than 0.84. Now, what you have to look at for this proportion, whether you're equal to, not equal to, less than, or greater than, is you have to actually see, is your 23 less than 84% of 100? And it sure is. So we are going to choose less than, which did match here, but sometimes they don't match. And they don't match when your person in this problem, this researcher, doesn't match the random number reality. So if this number wasn't 23, if this number was much, much higher, if this was like higher than 84, then you would choose the greater than symbol. because you're finding out that even though our alternative was this, the reality was it's greater than, and you're going to find the percentage chance of that actually happening. So if you are using a phone app, make sure on the phone app that you use calculate, because the draw function doesn't work. And there's a whole second video that I've made for those of you using the phone app. If you click draw, you're going to have to learn how to zoom in and zoom out. So you can use the draw function, but not until you get to the point where you've seen that other video, because the phone apps do not auto zoom like these graphing calculators do. So I'm going to click on calculate, and draw is really great, but let's click calculate for this example, because in the videos you've already watched, you've already probably seen me do all the draw functions, which you'll have to do on the paper pencil assignment. So there is your z-score. Your z-score is -16 standard deviations away from the norm. Holy crap, right? We thought being 2 standard deviations below the norm was bad. Imagine being 16. And then your p-value, which is down here, rounded to 0.4 decimals, it is 0. And I want to highlight the fact that sometimes they give you an exponential number, something with the letter e. If it gives you a number, and the number will be bigger than 1, like maybe 5.623, e -5, this is telling you that you need to move that decimal of the 5.6, whatever it was, you need to move that 5 decimals to the left. And if you forgot about exponential numbers, you may want to read my rounding rule FAQ, which FAQ is like short for frequently asked questions. That fact sheet is in my Moodle shell near the top of the page, unless it got shifted downward, but it was in Unit 1 when we did our rounding rule. So again, look up the rounding rule fact, or remember what you learned back in Math 102 or Math 105 about rounding exponential numbers. But a lot of times it just gives you the 0 if the number is close enough to 0 where it can be counted to 4 decimals. So you can put it there. Now, you know whether to reject or not reject basing on your work from 9.1 through 9.4. Our p-value was lower than 5%, so you'll choose correctly. And then you'll choose the conclusion statement, which actually has you do some analysis. Like, what are you actually saying when you're rejecting the null hypothesis? And remember, the null hypothesis was 84%. I guess we're rejecting that 84%, so there's definitely sufficient evidence to show that the 84% is crap. All right, we're going to have to get rid of it. All right, so again, in this situation, again, since these are randomized answers, you have to read these problems, and that's the college level of this course. Do some analysis of which one is this sufficient or non-sufficient evidence. You know, it looks like, you know, we're taking out the 84% from this rejection. Okay, so now we're going to go to question 2. Yeah, we'll leave there. Like the previous problem, we have a situation here where it's a p-test, but you'll notice that, a proportional z-test. The proportional z-test, again, I know that because it says 10% right at the top there. That is a dead giveaway. And also this verification check step here of the NP times 1 minus p, or the complement of p, this is only in the one proportional z-test. So what's cool about this multiple choice here is that you do get to see some null hypotheses with, you know, equal signs in them and less than or equal to. If you're writing a null hypothesis, always use equals. Don't get fancy and put less than or equal to or greater than or equal to. There's a chance you might get those flipped around. So just always use equal to. But another thing I want to highlight is 3 of these 6 answers are absolutely wrong because they use mu. If you're using a proportional z-test, we're not testing averages, we're testing percentages or proportions. So if you see a mu in your answer, let it go. For proportional problems here. See a mu, let it go. For proportional z-test, that's probably not easy to remember. And then you can Tell me if it's left tail, right tail, or two-tailed based on which one you chose. And of course, the problem randomizes and it says the veterinarian believes the proportion is, and you're going to say, going to say greater than or less than or not equal to. And then, again, these are all randomized. But here's where things got a little tricky, because if you're feeling like this is exactly like the previous problem, this problem takes kind of a big twist on part C here, because instead of giving you X, it makes you figure it out. So in this problem, I'm going to scroll down to the one proportional z-test, which is option 5, in the tests menu in your statistics part of your calculator. So you click on that, and then we go to our P0 up here, which is 10%, so 0.10, and it will eliminate that 0 for me. But now it asks for X, and so many people want to type in 4. But it's not actually 4, because that 4 is 4% of 700. Our X is how many people had that characteristic, or the P characteristic, that I was looking for in the study. So what you have to do, either on a separate calculator or before you get to this screen, you have to figure out what is 4% of 700. And from your previous math class, either in 102 or 105, they worked with translations, which is turning numbers and phrases into problems. And because it was one of the thousands of things that you did in those courses, it's probably something you don't really have right at the top of your memory. So this 4% of 700, 4% is 0.04. 0.4 would be 40%. So if you did 4% of 700, that's 0.04 times 700. And that would give you 28. You can actually do the same thing in the graphing calculator, this 0.04 of 700, because in math, multiplication, or of means multiplication. So if you want half of 100, you go 1/2 times 100, which is 50. And you can see that that makes it 28. So that's pretty nice. You actually don't need to back out of the screen as long as you're typing in X what this makes. Just make sure that your N is 700, because remember, this isn't always going to be 100, and that's also a problem that some people come up with. And now what we get to do is we get to, compute this, and again, choose the correct one and go to calculate or draw and then finish the problem. So that is something that happens in the second problem that switches it just slightly from the first problem. So that should get you through problem 2 pretty well. Problem 3 is like problem 2 with a different situation. And here, they're going to ask whether this is a T. So far everything seems to be going well here, because you still have your right-tailed, two-tailed. But look how this is different. In part C, you have to decide even before you do this problem, is this a T or a Z score? Well, if you're dealing with a one prop or one proportional z-test, then yeah, this is a z statistic. Notable that the sample size is pretty large, so here in this problem we're going to put in our P0, which in this case was 0.40, and it will kind of eliminate that 0 once I hit enter. And again, instead of us given X, like in problem 1, this is another 33% of 300. So we're going to type in our 0.33 times 300. Be aware that on the test, I could give you a problem like problem number 1 or a problem like this one. So you got to read carefully and know what you're doing. So, blam, there's 99 out of 300. Make sure that N is not, this is not, the same from the last problem. It is completely possible that random number generators can generate the same number 2 times in a row. It's just not very likely. And then this will calculate your z-score and then give you the p-value, and then you can do the end of it. So that's problem 3. You see how each problem is just a little bit different than the one before? So as soon as you just get one problem done, you're feeling like, I know how to do this. And then they just change it a little bit on the second problem and then the third problem. So, this is really I didn't want to give you 15 of these of each problem here. So, yes, every problem is going to be just a little bit different. And let's look at problem 4. Now, you'll notice in problem 4, right away in the preliminary, there is no check for N times P times 1 minus q, or 1 minus p, excuse me, the complement of p. And that is here to show you that this is probably a z or a t-test. Let's look at the problem. It asks in the preliminary, is n greater than or equal to 30? That's really your basic check for whether this is a z or t score. Remember, another check is to whether you think that this is a sample or a full population. And here's the thing. Some people can argue that this is a t-test. And it's an arguable t-test, even though the sample size is greater than or equal to 30. You got 100 people here. You can argue it because this is a sample of a population. And the sample of the standard deviation is what they give you, and not the actual known standard deviation of the entire population. So this gets a little bit into the weeds, because when you get to determining the test statistic, you'll notice it says t, which again, if you ran this as a z-test, it's going to be fine, because again, as we learned from the previous chapter, in chapter 6, chapter 8, pardon me, as we learned in chapter 8, as the sample size gets bigger, it inflates the normal curve, and we get to a point where the t-curves look like the z-curves, so they're statistically insignificant. So even though some of you may have done a z or a t-test for this, so when you go to your calc and click stat and move over to tests, you may have chosen z-test because of the sample size, or you may have chosen t-test because of this t equals. Because of the large sample size, both answers will be right, even though the equations that we use to compute this are actually different, and it's done under the hood of the graphing calculator. The p-values might be different if we're close to 30. So if this number, in this case, this number is 100, in case this number is close to 30, you may want to default to the t-test here. But if it's far away from 30, if it's way far away from 30, you can do z or t. But if it's getting close to 30, even if it's over 30, you may want to lean on that t-test because it gives you this right here. Okay, so that's my only warning. And on tests and situations, I'm going to make sure that either the sample size is miles away from 30 or exactly 30, which then you would use the z on my written test, hint, hint. But also it would be like well under 30, like in a table. That's a hint for what you're about to see. Okay, so in question 5, they're telling you right at the start here, p equals. So this is a proportional z-test. And students at this level, if you've gotten through questions 1 through 4, doing another proportional z-test, this one is going to be actually easier. In fact, they give you here, check it out, 105 of the 190. They're giving you x and n, just like I do in my problems nearing pages 15 and 16, or nearing 14 and 15 on the notes. Again, these page numbers may be different if I decide to change notes a little bit, but here we are in question 6. Question 6 is a t-test, and it's a t-test because we have a sample size that's under 30. Check this out. This is going to be a no, but it is safe to assume, yes, that this is less than 5% of all doctors. Remember the first preliminary question, is your n less than 5% of everybody? Yes, but the sample size is not. So what we have to do is an outlier check. And to do a proper outlier check, you should look at this box and whisker plot. And since we know our Q1 and Q3 as being this like 86 and 94 here, we multiply the difference, we subtract the difference between Q1 and Q3, multiply that by 1.5, add that to the difference from our Q1 and the Q3, and we see, huzzah, that there are no outliers. But more importantly, you can actually look at a box and whisker plot and see that there are no outliers, because an outlier would be represented in some box and whisker plots by a dot. So in fact, your graphing calculator has this function if you know where to look for it. I know you computed outliers by hand, but if you go second y equals and then click enter, you can go to, under the type, you can go to this option before the box and whisker plot. This option before the box and whisker plot will actually allow you to see outliers as little dots. As this box and whisker plot has no little dots to indicate an outlier, we're moving on, and you can click there are no outliers, this option here. Again, these are random, so it could be at the top or bottom option. Please read carefully. And this says there aren't outliers from the box plot. And by the way, if there were, we'd be done with the problem. Also, you'll note that this calculator is doing something that I make you do in your paper pencil assignments, because it says, without being given that the population is normally distributed and a sample size is less than 30, we are required to verify there are no outliers by plotting a box plot and a normal probability plot. So we have near normality here because of its symmetry, but also there are no outliers there as well. All right, so that was a whole lot of explanation for something that may not show up in your life, but if this is on any preliminaries for your next stat class, you better know that. So here we have our, our mu drop from the drop-down menu, and so again, you didn't have to type in the letter U, which is kind of nice or fine. Go find this on your keyboard, I dare you. Okay, so you can kind of go through the rest of this, and I would, since you have the raw data here, I would go into your stat, and instead of going over to your tests first, I would click enter and enter all of this into list 1. Okay, and please double check and triple check that you've entered this into list 1. So when you type in your 93.12, enter all of these numbers in list 1, and then when you go to stat and move over to tests, choose t-test, okay? Choose t-test, hit enter. And then instead of choosing the stats, choose the data. And that way you can click in your mu sub naught. In this case, it was 88. And then your list 1 is list 1. This is where you type in all your data. Your frequency is here. You will choose whatever this is talking about. It could be not equal to, less than, or greater than, and then click calculate or draw if you have the graphing calculator, and you'll be given your test statistic, your t-score, and your p-value. Then make your decision from the drop-down menu and your conclusion from the drop-down menu. So this was the first t-test in this homework assignment. So you've seen now all of the possibilities. You've seen the one prop z-test, multiples of those. You've seen your z-test with a large sample size. And again, that one was kind of interesting because you could have also done that as a t-test and still got the problem right because the sample size was so large. And now you've seen the one that can be only done with the t-test because the sample size is so small. Okay, so that was question number 6. Let's look at question number 7. Yes, I'll leave. Question number 7, this is another problem, but again, since we have 58 students, what's tricky about this one is that you might be inclined to do the z-test, which in a lot of situations will work out just fine, but because this is a sample, and the sample standard deviation is 0.08, this is safer to run as a t-test. Okay, now again, on my tests, on my written tests, if the sample size is over 30, always go z, okay, because it's going to be from a big population. I'm just going to make it binary. If it's exactly 30, if I give you 30 pieces of data, run a z, okay? Run a z because that will be all 30 pieces of data, which will be that population. But if it's under 30, always run a t. Okay, so we're going to now put some definitives in here. If it's under 30, always run a t. If it's 30 pieces of data, run a z. But if it's over 30 pieces of data on my written tests, run a z. But on these XYZ assignments, this might be good as a t, because remember, a t-test is used for sample standard deviations. We don't know the population standard deviation. And this sample standard deviation, it says it right there, with a sample standard deviation, so that technically counts as a t-test. Although, some of you may have gotten through your homework and did this problem fine because, again, with a sample size as large as 58, that t-curve could be statistically insignificant to the z-curve and the z numbers. But again, run a t-test just in case. And again, everything else will just line up fine. Question 8, last question here. One prop z-test. Okay, but the one prop z-test is going to run into a little snafu, because when you get done with this one prop z-test, you will see that this one prop z-test does not have an answer greater than or equal to 10. Womp womp. So what that means is you can't use the one prop z-test on the calculator, or you shouldn't, because the one proportional z-test works if and only if your n times p times q, or n times p times the complement of p, is greater than or equal to 10. And that's not going to happen here. So just to show you this example and what I'm talking about, your 11.1 from your 44 births, which happens to be your n, okay, that happens to be your n here. And I would say, as a side note, that this problem has a little bit of a tricky wording in it, because it says in the first sentence, 11.1% of all live births in the United States were to mother under 20 years of age. I had a few students who thought that this is a left-tailed test and the sample size is 20. But what the sentence is really saying is this: 11.5% of all live births in the United States were to teen mothers. So the under 20 years of age is just literally talking about teen pregnancies. So the 20 is not n, the 20 is not x. This is not guaranteed to be a left-tailed test. That is generated randomly by the XYZ homework, so be aware of that. Now that we've got that out of the way, let's show you the fail, the epic fail of this 44, which is the number of births here, and the 11.1, which is going to be 0.111 as a decimal. And then we're going to multiply that by the complement of 11.1, which is 0.111. And then we have an answer that's less than 10. It's 4.3, rounded to one decimal place. So if you look on the bottom of page 16 or on the bottom of page 6, these, again, page numbers might be off if I change my notes a little bit, but it says if this fails, you have to use the binomial distribution. And the binomial distribution is a review of chapter 4. Now it says, without being given that the population is normally distributed and that blah, 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 less than 10, we cannot assume a normal distribution and we're required to use a binomial distribution. This problem is literally giving you the answer. But that is the answer to this. So what this means is that you'll note that this problem does not require a z-value because we can't use the z-test. We have to use the binomial CDF. Now, if that seems familiar, but like way in the past, it is. It's back in chapter 4. So we got the binomial distribution by going second vars and clicking up to the binomial CDF, which is part of one of the menu options if you click the second button and the vars button. So the binomial CDF in this calculator asks you to input these things. And in this case, our number of trials were 44. Our percent value that we're testing against is 0.111, which is 11.1. And the x value in this case was 4. Okay, because that is what we assume from our problem. And then I'm going to paste this into the calculator. So if you don't have a newer calculator or you're using the phone app, you might have to program this in, where the binomial CDF works with 44, which is our n, our p, which is our 0.111, and this means 4 or fewer, so 4, 3, 2, 1, or 0. And this is our p-value, which is 45%. And I'm actually going to check this out here. It matches there. There's our 45%, and kablamo, we got our problem right. So this is what we need to put in for our p-value. And 45% ain't rare. 45% is much bigger than our alpha. And remember, if alpha's not given, alpha's always 5%. Don't forget that. So that takes us to our last problem, a very obscure one prop z problem that we can't use the one prop z test on because it failed our preliminary work in part B. Our part B was 4.3. So that should get you through all 8 of Chapter 9, Section 5 problems, or if I add more of them, you at least have some idea of what the skeletons of all those problems look like. So if you've watched this video and paused and rewound and paused and rewound and you feel like, man, I did my Chapter 9, Section 5 homework, but I didn't get a great grade, maybe you want me to allow this one-time unlock and redo. So send me an email and say, hey, I want to redo Chapter 9, Section 5. Go for a higher homework score. Now, the trade-off is that I have to erase your entire work. So you can't just redo the problems you got wrong. You got to do them all over again. But for a chance at 100% on a homework assignment, why not take that time and practice for the test that's coming up? That's going to have questions from this section and any of the other sections here in the biggest, kind of coolest section of our statistics class, which is the Introduction to Hypothesis Testing. Thank you for watching this long video, and I appreciate your hard work.